Welcome to our online chemistry class. Myself, Mukesh Kharge from SSPMS and Junior College, Shivajinagar, Pune 5. Our topic is Introduction to Polymer Chemistry. In this part, we are to discuss some important polymers. Here, we have to discuss some polymers such as Bakelite, Melamine-formaldehyde polymer, natural rubber, synthetic rubber. In that, we have to discuss Buna S, Buna N, Neoprene, Viscose rayon, some biodegradable polymers such as PHBV, Dextron, Nylon-2-Nylon-6 in detail. Let us discuss one by one. So first one is phenol-formaldehyde polymer, that is Bakelite. So phenol-formaldehyde polymer are the oldest synthetic polymer. These are obtained by condensation reaction. Condensation means the reaction in which small molecules such as water or methyl alcohol are removed during the reaction. So condensation of phenol with formaldehyde. So this is your phenol C6H5OH and this is formaldehyde CH2O or HCHO. And reaction takes place in presence of either acid H plus or a base which is used as a catalyst. So the reaction start with initial formation of ortho and or sometime para hydroxy methyl phenol derivative. Okay, so here three products are formed. Out of that, first one is ortho hydroxy methyl phenol derivative. Okay, that react with phenol and form compounds having a ring joined to each other through CH2 group. So n number of molecules of this compound react together. So OH group of one molecule and H from that another molecule. So let us suppose this is one molecule, the OH from this molecule and the H from another type of same molecule. They remove as a water and there is a formation of linkage. So this CH2 group get linked together with the another carbon of second molecule and in this way chain grows and there is a joining of two compound with this CH2 and such a compound is called as nolac. Then this nolac on heating with formaldehyde undergo a cross-linking to form a infusible solid mass like such a structure and that compound is called as bakelite. Okay, it is cross-link type of structure and it is used making comb, phonographic records, electric switches, handles of various utensils. Then melamine-formaldehyde polymer. This is second type of polymer. Here melamine, this is a melamine compound. It is heteroaromatic compound, react with formaldehyde HCHO. So the hydrogen from this NH2 group of melamine react with carbonyl oxygen. So what is the change here? The NH2 group contain one lone pair of electron. That lone pair of electron will attack on this carbonyl carbon C double bond O group and CO get converted to COH. So in short, this hydrogen from NH get transferred toward this oxygen of carbonyl group and there is a formation of NH dash CH2OH. So this is a resin intermediate, that is called as resin intermediate. It undergo polymerization. So again, if you consider this molecule, the OH group from one molecule react with hydrogen from another side of second molecule, and there is a removal of water. So this OH and this hydrogen from second molecule remove as a water, and there is a linkage NHCH2 again NH, and same molecule get repeated. So in this way there is a repetition, and that polymer is called as melamine polymer. It is used in the manufacture of unbreakable crockeries, and it is a cross-linked polymer. It is also a thermosetting polymer like your Bakelite. Next type of polymer is natural rubber. So rubber is a natural polymer and possesses elastic property. It is also termed as elastomers and has a variety of uses. It is manufactured from the rubber latex, which is a colloidal dispersion. Okay, so dispersion, colloidal dispersion, that you already learned in standard of rubber in water. This latex is obtained from the bark of rubber tree, and it is found in India, Sri Lanka, Indonesia, Malaysia and South Africa. So how it is prepared, let us discuss. The natural rubber may be considered as a linear polymer of isoprene. So this is your isoprene. So what is isoprene? It is 2-methyl 1,3-butadiene, and that natural rubber is also called as cis-1,4 polyisoprene. It is formed due to addition polymerization. That's why it is called as addition polymer. So here also we can discuss how it is formed. So when the CH2 carbon of first molecule form a CH2 carbon from another end of second molecule, and if it is form a bond with that, then the double bond between these two carbon shifted here. Okay, and in this way chain becomes elongated and we get a natural rubber as a product. So trans 1,4 polyisoprene occurs naturally as a gutta percha, which has a zigzag chain fitting in one another, and it is non-elastic and crystalline. Remember this word, it may be asked in MCQs. So this is about the natural rubber. Then what is vulcanization of rubber? Many times question may be asked. Write a short note on vulcanization of rubber. So Charles Goodyear discovered the process to make the natural rubber more strong, tough and elastic, and when it undergo vulcanized. So natural rubber is not much more stronger, tough and elastic in nature. That's why there is a need of vulcanization. So what is vulcanization? The process by which a network of cross links is introduced into an elastomers. That process is called as vulcanization. So natural rubber is mixed with 3 to 5% of sulfur, and it is heated at 100 to 150 degrees centigrade. It forms a cross-linking of cis-1,4 polypropylene chains through disulfide bonds. So bond between two carbons are through sulfur linkage. That is called as disulfide bond. And sulfur cross-links in vulcanized rubber. So between two chain of that 1,4 polypropylene, the sulfur is introduced to form the bond between them, and it form a cross-link type of structure. That structure is nothing but vulcanized rubber. So network or cross-link polymer. Linking of chain polymers by strong covalent bond leads to network like of structure or closing type of structure. That structure is called as vulcanized rubber. So here is the reaction: cis-1,4 polyisoprene react with sulfur and it form a cross-link type of structure, that is vulcanized rubber. Examples are melamine, bakelite and vulcanization of rubber. These are some network or cross-link polymerization. Why there is a need of vulcanization? It makes the rubber strong, tough and elastic. When natural rubber is heated with 3 to 5% of sulfur, that gives cis-1,4 polypropene with disulfide linkage. Then next one is some preparation of synthetic rubbers. First one is neoprene. So neoprene is also known as polychloropropene and it is obtained by free radical polymerization of chloropene. What is chloropene? It is 2-chloro 1,3-butadiene. When n number of molecules of this undergo polymerization in presence of oxygen or benzoyl peroxide, the carbon of this last carbon of first molecule, that is the fourth carbon, get combined with first carbon of second molecule, and then the bond between first and second get transferred to second and third. So here we obtain a double bond between second and third. So in this way that group get repeated n times. So that compound is called as neoprene. And which are the properties of this neoprene? It has superior resistance to vegetable and mineral oil, and that's why it is used for manufacture of conveyor belts, gaskets and hoses. Then second type of synthetic polymer is Buna S, or it is also known as styrene butadiene rubber. It is SBR rubber. Why the word is there? Because the monomers are 1,3-butadiene and styrene. So when 75% of 1,3-butadiene react with 25% of your styrene, then they undergo polymerization, addition polymerization by action of sodium. So what we get? If you observe the structure of your Buna S polymer, it is a copolymer. Here we can observe that the CH2 group of 1,3-butadiene form a bond with this CH2 of styrene, and the double bond gets shifted to next bond formation. So when this first carbon of 1,3-butadiene form a bond with this carbon, then this double bond gets shifted here and the ending CH group of styrene form a bond with the ending carbon of 1,3-butadiene. So in this way there is a formation of butadiene styrene copolymer. Here C6H5 group is a branch, so it is a branch chain polymer and it is used in tire industry. Okay. Then next is viscose rayon. So viscose rayon is a semi-synthetic fiber, and here cellulose is used as a monomer. So what is cellulose? Is a linear polymer of glucose unit and has molecular formula C6H10O5 N times. Now for writing the reaction, same formula can be written as cell-OH. So this cellulose in the form of wood pulp is treated with NaOH to get a fluffy alkaline cellulose, cell O minus Na plus water. Then this Fluffy alkali cellulose is then converted to xanthate by treatment with CS2, that is carbon disulfide. So we get cellulose xanthate, cell O C double bond S, S minus Na plus. Then on mixing with dilute NaOH, it gives viscose solution. So here cell O C double bond S, SO minus Na plus react with water first. Here Na get replaced by hydrogen, and this Na and the OH from water gives NaOH. Then this compound which is obtained react with another molecule of water in presence of alkali. Again the SH get replaced by OH and we get H2S. Okay, plus C double bond S, that gives CS2 again. So this C double bond S with this S gives CS2. Then this hydrogen goes here and gives OH. Okay. Then next one is the Buna S. So Buna S that we already learned. Now we have to discuss Buna N. It is obtained by copolymerization of 1,3-butadiene and acrylonitrile in presence of peroxide as a catalyst. So here the CH2 group of 1,3-butadiene form a bond with CH2 group of acrylonitrile. When it forms bond with this, then this carbon becomes pentavalent. So double bond between this CH2 and CH is used for next bonding formation with again the CH2 group of second molecule of 1,3-butadiene. In this way there is a chain elongation and we get Buna N. Which are the properties of this compound? It is resistant to action of petrol, lubricating oil and organic solvent, and that's why it is used in making the oil seal and tank lining. Then there are some commercial polymers, their names, then the monomers from which they are prepared, their structures and uses. Remember this, it may be asked in short questions for 1 or 2 marks. So polypropylene, it is obtained from polymerization of monomer. Structure is a dash CH2 dash CH CS3 n times, and it is used for manufacture of ropes, toys, pipes and fibers. Then polystyrene is the polymer of styrene. So structure is dash CH2 dash CH C6H5 n times. It is used as insulator, wrapping material, then manufacture of toys, radios and television cabinets. And next polymer is PVC, polyvinyl chloride. The monomer is vinyl chloride. Your structure is dash CH2CHCl n times. So it is used in manufacture of raincoats, handbags, vinyl flooring and water pipes. The next one is urea formaldehyde resin. The monomers are urea and formaldehyde. The structure is dash NHCO NHCH2 n times, and it is used for making the unbreakable cups, laminate sheets. Glyptal. The monomers are ethylene glycol and thalipic acid. So structure is dash OCH2 dash CH2 OCO, then benzene ring. Again it combined with CO n times. Manufacture of paints and liquors. Bakelite is obtained from phenol and formaldehyde as a monomer. So structure is like this. It is used for making the combs, electric switches, handles of utensils and computer disk. Next one is some synthetic rubber. Just now we see the detail. So for preparation of Buna S, styrene N13-butadiene as a monomer. For preparation of Buna N, acrylonitrile N13-butadiene as a monomer. For preparation of neoprene, 2-chlorobuta-1,3-diene is used as a monomer. And for viscose rayon, cellulose is used as a monomer. Then last point of this topic is biodegradable polymers. So biodegradable polymers are natural polymers. They are affected by microbes and they can easily degrade. But non-biodegradable polymers are synthetic ones and are not affected by microbes. Non-biodegradable polymers are stay in the environment for long time as solid waste material and they create pollution hazards. Hence, there is a need to develop the biodegradable synthetic polymers which are environmentally friendly or eco-friendly. They are generally copolymers and there are two types of linkage in that copolymer. If there is a ester linkage, the examples are PHBV and Dextron. If there is a amide linkage in that copolymer, the example is Nylon-2-Nylon-6. Let us discuss in detail. First, PHBV type of polymer. The full form of PHBV is poly-beta hydroxy butyrate, co-beta hydroxy valerate. So this PHBV is a copolymer of two bifunctional beta hydroxy carboxylic acid and they are beta hydroxy butyric acid, or it is also known as 3-hydroxy butanic acid, and beta hydroxy valeric acid, that is 3-hydroxy pentanoic acid. So the hydroxyl group of one monomer form ester link by reacting with carboxyl group of other. So here this OH group of 3-hydroxy pentanoic acid will attack on carbonyl carbon of the COH group of 3-hydroxy butanic acid, and there is a removal of hydrogen from this OH and OH from this COH as a water, and we get a compound. That compound is called as PHBV. You can easily understand this type of formation. And if you observe here, the dash C double bond O dash O means ester linkage is present. So it is a ester linkage polymer, copolymer. Then next one is the dextron. During the formation of dextron, lactic acid and glycolic acid are used as a monomer. Here also the OH of glycolic acid will attack on carbonyl carbon of lactic acid, and there is a removal of hydrogen from this OH and OH from this COH group of lactic acid as a water, and there is a formation of CO dash O CH2 CO linkage, and that linkage is nothing but dash C double bond O linkage. It is again a ester linkage. So your PHBV and Dextron are copolymer with contain ester linkage. Then next one is the Nylon-2-Nylon-6. So Nylon-2-Nylon-6 is a polyamide copolymer of two amino acids. What is amino acids? The compound which contain NH2 amino and COH as a functional group. That compounds are called as amino acids. So here first amino acid is glycine, second amino acid is epsilon amino caproic acid. So here the NH2 group of this epsilon amino caproic acid will attack on carbonyl carbon of, that is COH group of glycine, and there is a removal of H from NH2 and OH from this COH group. It removes as a water, and there is a formation of dash CONH2 linkage. CONH linkage, that is called as amide linkage. So that's why it is a amide linkage polymer. It is also a copolymer, and so all these three copolymers are degraded by bacteria in environment. So they are biodegradable synthetic polymer, and they are used as a orthopedic device, implants, sutures. So here some questions are asked in board exam based on this introduction of polymers. So you can write their answers. Then thank you for watching my video. If you like this video, you can subscribe, share my YouTube channel Mukesh Kharge. Thank you very much.